In this example, we are looking at some information from 157 bills from a bistro in New York State. The larger data set contains the amount of the bill, the size of the tip, percentage of the tip, number of customers, etc. And we have a mixture then of categorical and quantitative data. In part A, we are looking at whether or not the tip that's left is dependent on the server here. So we're going to look at an ANOVA to be able to see if the population mean tip amount is the same or not for the three different servers. We are given a partially completed ANOVA table, and so we need to try to fill in the rest without doing everything from scratch. So first of all, we can fill in our degrees of freedom by noting that the number of groups is 3 because we have 3 servers. The total amount of data is 157. We're told here we have 157 bills, or if you add up these 3, we get 157. Our 3 sample sizes here are different for the 3 groups. We have N1 of 60, N2 of 65, and N3 of 32. So our degrees of freedom are K minus 1, which is going to be 2, N minus K, which is 157 minus 3, so 154. If we add those together, we get 156. That is 1 less than N. At this point now, we can use the numbers in the table to fill in the rest. We are given an 18.95, and we know that if we take the sums of squares and divide by 154, we should get back 18.95. So that tells us if we take the 18.95 and multiply back by 154, we'll be able to get what the SS was. So we know that the MS within is the missing SS within over 154, and this was the 18.95. So we're multiplying back. We will get for that value then 2,918.3. Then remember that the sums of squares, this one, the between, and the within add up to the total. So if we take the total and subtract off what we just found, we will get the other one, which is 82.7. Now 82.7 over 2 is going to give us our mean square, 41.35. And then finally F will be 41.35 over 18.95, and that is equal to 2.182. At this point then we can go to StatKey using degrees of freedom 2 and 154 and get our p-value. So we go to F, we put in 2 and 154, and right tail, and put in our test stat of 2.182. So we get a p-value of 0.116. The other pieces of this problem then are on the next pages here, and I've already written out a lot of it. So our test, after we've filled in our ANOVA table, is testing if the means are the same. That would be the population mean is the same for all the servers. The alternative then is that at least 2 of those differ. Our p-value is 0.116, and so here we would fail to reject the null because that is greater than 0.05, and we'd say that we do not have evidence of a difference in the population tip amount for the servers. At this point, we really would not need to do differences in means because we just said we do not have significant differences. So part 2 is really no, we wouldn't have to do this. But part 3 is regardless, do it anyway. So in part 3, what we're doing is comparing the groups 2 at a time. So we're taking the 2 sample means, which are the 2 X bars. These would be the X bars for the different groups, which we had in the table before, adding and subtracting our T, and I'll talk about where we get that in a second. Multiplying by the square root of the MSE or MSW, which was 18.95 in the table, and then these are 1 over those different sample sizes for the different servers. And notice they are different in each one. Where we get the T, remember we take the number of intervals we're doing, which we have 3 here. We chop the error down by that amount, so our error of 0.05 divided by 3, and we take 1 minus that. This is the confidence amount we really want to use to have an overall 95% level. Our degrees of freedom we use is the degrees of freedom within, which was 154. So we go look up a T for these when we're comparing 2 at a time. Degrees of freedom was 154. And then our confidence amount that we want in the center here for an overall 95% rate is 0.983. So you can see we get 2.413. Okay, so that is where I'm getting that T from. So these three intervals that you calculate out are given here at the end, and notice that they all contain 0, contain 0, contain 0, contain 0, which makes sense because all of them containing 0 would mean we do not have any differences, and that is what we already said. So this step here of looking at these intervals is actually not necessary if we fail to reject the null, because we've already said there are no differences. The other parts of this problem in parts B and part C are actually going back to chapter 7, doing a chapter 7 goodness of fit test in part B, and then the next one is a test of independence. So I'm not going to actually run through these here. You have the notes for them. But so this is sort of meant to compare, contrast the different things we're doing in chapter 8 to what we're doing in chapter 7, based off like the type of data we have and the different types of questions we could answer within a larger data set.